Hello Math AI students, these are notes for lesson 8.1, Sine Rule in Triangle Area. Our essential question is, how can trigonometry be applied to all triangles? So when we worked with trigonometry earlier, we focused only on right triangles, but this unit we're going to specifically focus on non-right triangles and how trigonometry can be applied to them. So the first thing we need to discuss is the area of a triangle using trigonometry. So if you can see here, I've got a triangle ABC, and I've drawn in a few things. I've first named all three sides, and the sides of the triangles are based off the angle directly across from them. So if you see here, angle A is capital A, and then directly across from it we have side A. We have angle B, and then directly across from that is side B, and then angle C, and directly across from that is side C. And notice that lowercase letters are meant for the sides and uppercase letters are meant for the angles. I've also happened to draw in an altitude of this triangle, and altitudes always form a right angle with the base. And this is the height, and altitude always represents the height of the triangle. And then I've focused here on angle C. Now why is that? Because it's going to help us derive the area formula. So normally, and you've learned this in the past, the area formula for any triangle is 1/2 times the base times the height. And this is a fantastic formula, and you should still remember it, but that's not always going to be helpful for us. Instead, we need to have a trigonometry-based formula. So to do that, I'm going to come over here and I'm going to look at angle C. Now, if you look at angle C, I'm going to write the sine of angle C, and I'm going to use this symbol to represent the angle C. It's like a little hat on top of it. So sine C is equal, remember sine is opposite over hypotenuse. So I have a right triangle here, so it's going to be the opposite, which is the H, over the hypotenuse, which is B. So it's going to be H over B. Okay. Now I can isolate H by multiplying both sides by B, and I have H equals B times the sine of angle C. Okay. Now since I just reminded you that the area of a triangle could be, I'm so sorry, I messed that up, that the area of a triangle can equal 1/2 base times height, we can do a little combination here. We can take our height, which is actually B times the sine of C, and plug this in to this formula. Okay, so we can do area equals 1/2. Now notice that there's this B. Well, what are we talking about the B? Well, the B stood for the base. Well, what was the base in our triangle? Side A. So times A times, now I'm going to substitute H is the values in for H, and I get times B times the sine of C. Now don't be confused. This B does not stand for base. I know it can seem confusing, but this B up here was for the base. This is actually side B. So this is actually our formula. Thus, the area formula for any triangle is area equals 1/2 times A times B times the sine of angle C. And there you have it. That's an extremely helpful and important formula. Make sure that you're comfortable with it. Now, notice we have side A, side B, and angle C. Notice what's happening here, okay? What's important is that you have two sides in the included angle. The included angle is the angle between those two sides. You could actually use any two sides. Like I could use angle A and angle C. I would just have to use the angle that's in between them, which would be angle B. So make sure you understand that angle C, let me put that over here, that angle C must be an included angle. Think of included as the in-between angle. Okay. So now let's see this in action. Let's look at an example here. It says a farmer owns a triangular plot ABC, and here's a picture where the lengths are AB equals 120 and BC equals 240, and the measurement of angle B is 130 degrees. We've got that there. So find the area of the plot to the nearest integer. Now notice I have two sides and the included angle. So we're good to go. Fantastic. Now, if you wanted to name the sides of this triangle using the naming convention I used up here, obviously that this would be side A, and this is side C, and this is side B. So notice it's not going to literally be the exact same sides as the formula, but that's okay as long as you understand it's any two sides and the included angle. So I'm going to do area equals 1/2 times 240 times 120 times the sine of 130. All right. So we can do a little bit of mathematics beforehand. 1/2 times 240 times 120 ends up being 14,400 times the sine of 130 degrees. And now you can grab a calculator and plug that in into the nearest integer. It's going to be 1031 meters squared. So you might want to go back, grab a calculator, and work through that as well. Now for example 2, I'm going to make this a you-do problem, but before I leave you to it, look what it's asking. Now it's giving you an area of a parallelogram. Now conveniently this parallelogram has been broken into two congruent triangles, and I hope that can kind of hint at what you need to do. So it's giving you a parallelogram and wants to find the area of the parallelogram. Now based on this example, you should be able to figure out the area formula for a parallelogram. So hopefully you're already starting to think, well, let's see. It looks like the area is 2 triangles, so I would have to double whatever the area of this first triangle is. But there's already a half there, so if you want to double 2 times 1/2 just equals 1. It cancels it out. So the parallelogram area formula would be area equals A times B times sine of angle C. Don't believe me? Go back, find the area of this triangle, double it and see what you get, and then go back and just plug in the values into this formula and see if it works out for you. But that's your you-do question. Okay, now let's move on to the back. So that was the area formula. Some of you may have seen that before, but now we're going to move on to something that's probably pretty new. It's called the Sine Rule, aka the law of sines. You'll hear me say them interchangeably, but they're the same thing. The Sine Rule, the law of sines. It says for any triangle ABC, where A is the length of the opposite side of angle A, so we'll do this. B is the length of opposite angle B, and C is the length of the side opposite angle C. So that's the same naming convention that I talked about on the front page. It says that this proportion exists. It says that side A over the sine of A equals side B over the sine of B equals side C over the sine of angle C. Or some people write it like this. They'll do the sines on top and the sides on the bottom, and that's okay. So it might be confusing what you're listening to me say, but it's sine of angle B over side B. So be careful that you understand exactly what I'm saying there. So we have this. Okay, well, what does this tell us? Well, typically you don't use all 3 sides and angles at the same time. You typically only see it with 2 of them. Okay, that this ratio exists, that if you take the sine of an angle A over its side, it has to equal the sine of angle B over its side. And this can come handy, and this is true for any triangle because you can use it to solve for missing values. So specifically, the sine rule is used when you when 2 angles, use it when you have 2 angles and 2 sides. And you're typically asked to find one of those. So you have 3 of those values, and you need to find the 4th. So you have 2 angles and 2 sides. Sometimes they'll give you 2 angles and a side, and they'll say, find the other side. Or they'll give you 2 sides and an angle, and they'll say, find the other angle. But it always involves 2 sides and 2 angles. So let's see how it looks. Let's do example 3, which I just noticed I misspelled. There's an E there. My apologies. So example 3 says down below, we have a triangle QRS. QR is 15 meters, and this is kind of blurry, I just realized, so I'm just going to write over it, 15 meters. SR is 6.5 meters. And angle S is 125. There you go. Find the measurement of angle Q. Give your answer correct to 3 significant figures. So hint, are we looking for a side, or are we looking for an angle? Well, I've been given 2 sides, and it looks like I need to find an angle. So notice I have an angle and the side across from it. Okay. And I have a side, and I'm looking for the angle across from that. Now, why do I care about it being across? Because remember, the law of sines, or the sine rule, deals with angles in sides across from each other. So right here, sine of angle A over A means it's the sine of this angle over the side opposite it, okay? So let's set this up. So I'm going to first start, it doesn't matter which variation of the sine rule you use, what goes on the top, what goes on the bottom. I'll do this. I'll do sine of 125 degrees over 15 equals the sine of angle Q, because that's what I'm looking for, over 6.5. Now you might be thinking, well, how do I solve this now? Well, I've got to get Q isolated. We have to get Q isolated. So the first thing I would do is just multiply both sides by 6.5. So let me grab a, multiply this side by 6.5, and multiply this side by 6.5. Okay, so this cancels out. So I'm going to rearrange this a little bit. So sine of Q equals 6.5 times the sine of 125 degrees over 15. So now what do we need to do? Well, I still need to get this Q. Oh, and I didn't put the angle symbol on top. I need to get it isolated. So when you're working backwards with trig, that's inverse trig, you're looking for an angle measure, you're going to have to use inverse sine. So to get angle Q, I need to do the inverse of all of this. I don't want to rewrite it. I'm just going to draw a little arrow down. I need to get the inverse sine of this entire value. So that's when I'm going to grab a calculator at this point. And I don't want to do any kind of rounding. I don't want to do that. So I'm going to grab inverse sine, and then I'm going to type in 6.5 times the sine of 125, and then divided by 15, and I get 20. Here, angle Q ends up getting 20.79135. You know, it keeps going, but it says to round to 3 sig figs, so I'll say that the measurement of angle Q is 20.8 degrees, and there you have it. Now, I would highly recommend you stop this video, pause it real quick, and actually grab a calculator or use Desmos and try to figure out this out on your own. Follow along with the steps and do the math, because the concept's not difficult. It's actually sometimes getting these things typed into a calculator that can be confusing. So from there, when you're all done, make sure that you do the you-do problem, you complete your summary here at the bottom, and you fill in any kind of guiding questions or annotations that you need to on the left-hand side. With that, I wish you the best and take care.